Okay, here's question number 3. This one's a lot like the last one. What I'd like for you to do is, after we read the question, pause the video and see if you can do the calculations on your own. Okay, and then start the video back again. All right, how many milligrams of the local anesthetic agent is in 1.8 milliliter cartridge of 2% xylocaine? Sounds a lot like the last one we did. Oh, it is, except for now we're using 1.8 instead of 1.7. All right, pause the video and see if you can do this on your own. Okay. My starting point is always right here, that 2% xylocaine or 2% lidocaine. I'm going to change that 2% to 20 milligrams of the drug per milliliter, which means per 1 milliliter. And I always kind of like to start there first. 20 milligrams of the drug per 1 milliliter. And the other thing they gave me is, this time is to use 1.8 milliliters per cartridge. 1.8 milliliters per 1. This time they're calling it a cartridge instead of a carpule. All right, that sets up my fractions. Notice that my milliliters cancel out. I'm left with milligrams per cart, or per cartridge, and that's what we're trying to figure out. So I'm going to take 20, and these are fractions. Remember, these are fractions, and I'm multiplying fractions. All right, 20 over 1 times 1.8 over 1. How do you multiply two fractions together? Well, it's straight across. There's your little math lesson for today. So that's 20 times 1.8 over 1 times 1 is 1. Remember, if you have 1 in the denominator, it goes invisible. So I'm just left with taking 20 times 1.8. I forgot to put my goal units in here. How many milligrams? That was my goal. Well, I obtained my goal. Milligrams per cartridge is what we're going to be calculating. So let me look at my calculations. I did all the number crunching last night. That gives me 36 milligrams per cartridge of 2% xylocaine. Okay. Is that what you got? Good. If that's not what you got, we can talk. Let's try number 4. I really like question number 4 because it shows you if you don't wind up getting what your goal is, you can approach it another way. All right, number 4. What is the maximum number of cartridges or carpules of Articaine 4% that can be administered for a healthy adult patient who weighs 150 pounds? Okay. I've got some givens here. That's a given, and that's a given. So the 4%, I'm going to put that over here on the given side. 150-pound person, that's a given. And it says, what's the maximum number of cartridges? That's what we're trying to calculate. So I'm trying to figure out how many carps I can give this 150-pound person. All right. So I just kind of always start right here. That 4% becomes what? Multiply by 10 and you get 40. And what's the units on that? Yeah, that's milligrams per milliliter. Or 40 milligrams of drug per 1 milliliter. So I'm just going to go ahead and put that on my line here. That's one of my givens. 40 milligrams per 1 milliliter of solution. Okay? Now the next thing that they didn't give me was the capacity of each cartridge. So I'm going to use 1.8 because I think that's what you guys are using. 1.76, or I think that's what I was told. A cartridge is actually 1.76, which rounds up to 1.8 milliliters per cartridge or per carp. So when I use this, I want milliliters in the denominator to cancel out with milliliters in the numerator. So I'm going to put milliliters there. I have 1.8 milliliters per one cartridge or one carp. Okay? Now this is the next thing that you need. I need to know what the recommended dosage is per pound. So let's go back to my chart, and this was Articaine. So I'm going to go back to this. This you have to look up. Here's the Articaine right here. The maximum dosage of Articaine that I found for a healthy adult was 3.2 milligrams. I think that's supposed to be per pound. I think I'm going to have to change that, and this is supposed to be per pound. All right, 3.2 milliliters per pound. I want you to double check that. I think that was just a typo on my part. So I'm going to use 3.2 milliliters per pound. Go back to our calculation right here. Let me write that down. 3.2 milliliters per pound. Or was it milligrams? Oh my gosh. It was milligrams. I knew it. When I wrote it down, I knew that didn't look right. All right. This is given to you by, I'm guessing, the drug companies, the drug manufacturers. It's something that you will have to memorize if they don't let you have this information on a test. The maximum dosage per pound is something you will have to memorize. Okay, so I can say that the recommended dosage is 3.2 milligrams for every 1 pound of body mass, or I can also write it like this. For every 1 pound of body mass, they recommend 3.2 milligrams of this drug. Now let's see what I've got canceled out here. This cancels with this. Milligrams here needs to cancel out with milligrams in the denominator. So which one of the two of these am I going to use? Am I going to use A or am I going to use B? Yeah, I've got to have milligrams down in the denominator. So I'm going to say 1 pound goes here for 3.2 milligrams. For every 1 pound of weight, it's recommended that you use 3.2 milligrams of the drug. And when I do that, those cancel out. And here's where the pounds comes in. Pounds in the numerator would have to cancel out with pounds in the denominator. So the 150 would go here in just a 1. Now look, your pounds cancel out. I've used all my numbers, but look where carps wound up. It wound up down in the denominator. And I don't want it in the denominator, I want it where? I want it up in the numerator. It's super easy to fix that. Let me show you what you're going to do. You're just going to flip everything over. Instead of saying there's 40 milligrams of drug in 1 milliliter, we're going to say in 1 milliliter, there's 40 milligrams of the drug. Instead of saying 1.8 milliliters in 1 carp, we're going to say in each 1 carp, there is 1.8 milliliters. And you can see my milliliters still cancel out. The one in the numerator cancels out with the one in the denominator. Here I'm going to say instead of for every pound you're going to use 3.2 milligrams of the drug, I'm going to flip that over. I'm going to say I'm going to use 3.2 milligrams of the drug for every 1 pound of body weight. And let's see here. My milligrams here in the numerator cancel out with milligrams in the denominator. Instead of putting the 150 pounds in the denominator, let's put the 150 pounds in the numerator. And if you want something in the denominator, just put a 1. Pounds down here cancels out with pounds up here, and I'm left with what units? Carps in the numerator, which is what I wanted. Okay? This right here didn't give us the results we wanted. It didn't give us our goal. When I flipped the whole thing upside down, it did. So now what I'm left to do is just the multiplication, or the math. In the numerator of my fraction, I have 1 times 1 times 3.2 times 150, or just 3.2 times 150. In the denominator, I have 40 times 1.8 times 1 times 1. 40 times 1.8 times 1 times 1 gives you that. And when I did the calculation, I got 480 over 72. And when you take 480 and divide by 72, I wound up with a total of 6 point, it might have been a repeating decimal like 666. I just rounded it to 6.7 carps of, what drug were we using? Articaine. What percent? Was it 2%? No, it was 4%. Was it 4%? Yeah, it was 4% right there. 4% Articaine. Using dimensional analysis takes out the guesswork of, do I multiply these numbers together or do I divide? And it also puts it in one big calculation instead of a series of like 3 separate little calculations. Right? I think it takes the guesswork out of it. It is something that's going to take some practice though, okay? So we're going to practice on the next problem.